Well, thanks for coming. I appreciate you taking the time on the morning. I want to just walk through some background to get you to the point where you might understand some of the circuits that drive the score reels. And we'll start with the very basics, and I hope to add complexity in layers, and at the end we will understand how this game scores, how it resets, how it adds multiple points, things like that. And this device will be available for your inspection for the rest of the weekend out in my booth, along with a lot of other gadgets that I brought with me. So with that, let's jump right in. I want to point out, so electromechanical devices or games require motion, right? We talk a lot of solid-state games, you have motion, but that's primarily to kick the ball around and to activate the toys and things. They don't require motion to do computation. Electromechanical devices rely on motion to actually do the computation, to open and close switches, to make things, to evaluate circuits in the game. So we have to understand how that motion is created to get to the root of how these things are working. So the question is, how do we create motion in an electromechanical device? We could use magnets, right? Maybe you've seen this picture in a former life or when in middle school or something. This is just a bar magnet, and this is showing you the magnetic field lines that surround the magnet. This is just a cross-section, right? Those field lines surround that magnet, kind of like a donut would. And if you were to slice through that donut, this would be a picture you would get. If you ever took a magnet and sprinkled iron filings over it, you might end up with something that looked like that. The way to read this is it's like a topographical map, right? The strength of the magnetic field that's created by this magnet is stronger where these lines are close together. So on a topographic map, when the lines are closer together, you're on a steeper pitch. And where they spread out on the sides and above and below this thing, it's a very weak, very gradual magnetic field. So when you attract something to a magnet, you're attracted to the poles because of this density, the fact that these lines are closer together. And if you're ever to take a compass and get it anywhere near this magnet, the compass would align itself with the nearest line. So that's how compasses work when you're hiking, right? The Earth is magnetic, and it's picked up on one of these lines, and it's just aligning itself and pointing towards the North Pole. But the problem with using magnets to create motion, right? Once a magnet has stuck on an armature or a plunger or something, there's no elegant way to pull that apart. You get to do it once and you're done, game over, right? So we need a way to control that magnetism so that we can actually do it more than one time, have the thing repeat. So what about electromagnets? Electromagnets are the final answer. That's what we're going to get to. But how do they work? How do we control the magnetism that's coming out of a device? And so I'd like to show a couple videos here to try to explain how that works. So what I'll show you here is an animation that looks like it's a piece of solid copper wire. And I will put electric current through that wire. And what you'll see is that as the current flows through that wire, an invisible magnetic field forms around that wire along the entire length of the wire. And it has a direction just like the poles on your bar magnet. The problem with this is that, as cool as it is, there's no way to control this. It's uniform across the length of that wire, so there's no way to attract a plunger or an armature to one section over another section. It's consistent across the length of that wire, and it's also very weak. There's not enough magnetic field here to really work with. So, but it's a first step, right? It's a way that I can create a magnetic field by and have it under my control. If I stop that current, the magnetic field disappears. If I were to take that same piece of wire and I build a loop with the wire and send the current through it, the same magnetic field forms, but inside that loop, suddenly these magnetic field lines get a little bit closer together. They're kind of concentrated, sort of like a lens concentrates light. A loop like this concentrates these magnetic field lines. So now suddenly I've got a place where it's pretty uniform along the length of the wire, but right inside that loop, the magnetic field has gotten a little bit stronger because I focused it in there. All those lines sort of combine together inside. So that's the next step. We're not quite there yet. This is still pretty weak, and there's not much I can do with just that. But the next step would be, what if I were to take this loop and stack up several loops above it? right? I can add all of the magnetic field lines from each loop, and they combine. So as current goes through this thing, the magnetic field lines are focused on the inside, right? Does that make sense? So now this starts to look like the bargain magnet I showed you a minute ago, right? This is the magnetic field, and I can control it now by sending current through that or not sending current through that. And this is the basis of all of the electromechanical devices, all of the solenoids, the relay coils, anything that creates motion is created by this electromagnet, which has a magnetic field that I can create or make go away or go away as I want to. So if I have this ability now to fabricate a magnetic field out of thin air, right, how do I control it? Well, I can take that electromagnet and give it a power source and a switch, and that now allows me to control the current that's going through that device. When I want, right now this is the switch here at the bottom is shown, it's open, so there's no current flowing through here. But when I close that switch, I create that magnetic field, which looks just like the one on the magnet. So now I can have that magnet activate and deactivate, activate and deactivate as that switch opens and closes. Okay, does that make sense? So, all right, so now I've got a way to create a magnetic field, but now I've got to figure out when to actually activate this thing and when to let go. And that's done with switches, obviously, right? We're going to open and close circuits to allow current to flow through that thing. And there are several varieties of switches that are used, but these are the most common ones. They're normally open switches and normally closed switches. On the left are the schematic symbol for them. And the arrows are meant to show you how that switch is activated, either by a relay or by a stepper or some other device, the out hole perhaps, activates. This is the direction that the switch would be activated in. And now I can control the current that's going to go through that coil. Most of these devices that use coils are going to use the magnetic field to pull something in one direction. But it's going to be a spring that actually pulls that device back to reset it in the other direction. So the magnetic field only works one way, and then I rely on a spring. So as that magnetic field pulls a plunger or a relay or something, it's actually stretching out a spring and putting energy in that spring. So when I cut power to that coil, that spring is what's going to pull it back to its steady or reset position. But just having a single switch and a coil isn't terribly interesting. What gets interesting is when I start to combine these switches in various patterns. And that's what determines the behavior of your game or the behavior of the device that you're trying to control. So here is a contrived example where I have a bunch of light bulbs and I have a power supply. This is a transformer at the bottom. And I just have different kinds of switches in different kinds of configurations. And all these lights are going to turn on at different times based on the combinations of switches that I've used. At the bottom of this picture, they could be targets, they could be relays, they could be steppers. It's just a device. So I have an A device and a B device. And when that device activates, it will flip all of the switches on that device. So if I, can I get over there? Can I get the whole slide, please? Yeah, there we go. Right. So if I activate A down here, then all of these switches are going to change from whatever state they're in to the opposite state, right? Switches only have two positions. Same thing with B. If I activate B, it will change all of these switches together, all right? So maybe they're all in this, maybe this is a relay and all these switches are stacked up in the same relay. Well, if I just apply power to the circuit the way it's shown right now, only some of these bulbs are going to turn on. And these bulbs kind of represent what's called Boolean logic, right? They are the basis of computation. So the first one, for example, that bulb would only light if both A and B devices are active. Okay, and I can walk down through that table and get the different functions. And I can make these arbitrarily complex. So if I apply power to the circuit, I only get two of these bulbs on, right? Because those are the only switches that provide a complete path for the current to flow through, right? So I get the A and B and the A NAND B and A NOR B, because neither A nor B are active at the moment. They're both false, essentially. But now if I activate the A device, all of these A switches are going to flip, and I'll get a different set of bulbs coming on. Now I get A or B lights up because A is true, right? B is still false, so I'm getting a different combinations of functions. If I turn B on, I get still a different set of lights coming on. At the very top now, I've got A and B is on because I've got both A and B active at the moment. And then if I turn A off and leave B on, I get still different combinations of switch, different combinations of light bulbs that are active based on those switches. So this is just meant to give you a flavor. I can build arbitrarily complex behaviors and functions just by combining more and more switches in different configurations and build up an arbitrary bonus count, an arbitrary reward system on a game. So let's look for a minute. What is controlling these switches? All right, let's have a good look at a relay. So this is a Bally relay, and the relay is built of a coil and a set of switches and an armature. So the coil that we talked about earlier, the electromagnet, is the coil in red here, is what's going to make this thing happen, right? What's going to make the relay activate. And the switches may be open or closed. We don't really know. We don't really care. But the point is when that coil activates, all of those switches are going to flip to their other state. They will either open or they will close when that relay activates. So when I put current through that coil, I'm going to get this magnetic field I talked about a minute ago, right? So the magnetic field forms going through the coil like that because that's the byproduct of putting current through that coil. So now that I've got this magnetic field, magnetism attracts iron and steel, right? So it's going to want to pull down on that armature piece, which is, can I reach? I don't know where my mouse is. Well, the top plate there at the top of the coil is going to move down. And that's just enough motion that it's going to activate all of those switches, right? So if I just put this in motion, every time that coil fires, you put current through that coil, the magnetic field appears and grabs that armature and pulls it down. That's what's changing all of the switches in that relay. And when the current is cut through the coil, the spring is what pulls it back up and allows all those switches to relax. Okay? And if you've worked on any EM games, you've probably seen what a relay looks like when it's activated, right? It's just opening and closing as I'm putting current through that coil. So far, so good? All right. Let's look at something that's a little bit more complicated. All right. This is a score reel. And the way the score reel works is there's a big frame and there's a wheel that turns with numbers on it. Let's see. There it is. OK. So there's a toothed gear that lives underneath the score reel disc. And there's a sort of a rack and pinion arrangement here that slides in and out of this coil. And every time that thing pulls in, it stretches this spring here and arms that score reel. And it's not until the solenoid or the score reel relaxes that the spring pulls forward. And that's what rotates your score reel. Okay? So I have the same coil again. The coil is a bit stronger. There are more loops going through it. There's more power going through it. It can pull more than just a little armature. It's pulling an entire plunger and everything that's tied to it. So when I put current through that coil, I get my magnetic field again, just like the relay. And what's going to happen is it's going to pull that plunger right into the coil. That's going to stretch the spring and drive that rack and pinion forward. And when I cut power, that is when the score reel will advance. And this is what it looks like in animation, right? That rack and pinion is moving back and forth every time you want to get another point added. And this will only take a single step every time this thing fires, right? So if I want 1 point, I fire it 1 time. If I want 5 points, I have to do this 5 times. I have to repeat it again and again. Okay? And this is what this looks like in real life. If you pay attention, you can see that the plunger pulls in, but the score reel doesn't actually rotate until the plunger is allowed to relax, right? Until the coil relaxes and the spring pulls that plunger back, and that's what walks my score reel forward. Okay? So let's go back to the circuit side of the house. This is a trivial example. I've got, let me walk through this a little bit. So this is a transformer here. This is a relay coil, okay? And this is a target, a switch that might live behind a 10-point target, okay? So, and this is just representing the target itself. So when the ball hits the target, this switch closes, it completes the circuit, I fire up that relay. The relay is going to send power over to my score reel, and this is the schematic symbol for a step unit, which is basically what a score reel is. And it will activate the coil on the score reel, and then when the circuit, when the switch opens, the ball rolls away, the switch opens, that's when the magnetic field disappears, the spring does the work of pulling it forward. So if I walk this forward now, you can see every time I hit the target turns green, the switch closes, sends power through the whole circuit. But it's not until the power goes away that the digit actually rotates to the next position. Any questions? No? We're good? All right. Oh, and so now I should point this out. So this is the working model of what you're looking at, right? So I have a target here that's represented by a button. Okay, it's just a single button. There's a switch underneath it. When I close the switch, the score reel advances. And it's doing exactly what you're looking at the animation here. I should have given you a heads up. Do you want to?
Sure. Holding the button down for a second so we hear the click come.
And you'll notice that it doesn't advance until I let go of that button, right? If I hold it, the score reel doesn't go anywhere. And it's not until I let go that it advances. Okay? I'm going to do 2 or 3 of these here in a minute, one after the other. All right. So this is what that circuit looks like when it's running. That make sense? Okay. Good, good, good. So that's one way I can advance a score reel. Okay, that's interesting. But there's another way, right, that maybe I don't have a target. Maybe I'm a 10-point score reel, and my neighbor in the 1-point score reel has walked up to 9. Well, something has to happen to carry from the 9 to the 10. So there has to be another circuit that behaves slightly differently that's going to allow that carry to happen. When you add numbers on a piece of paper, right, in school you were doing it on paper, da-da-da-da-da, and carry the 1. Well, this is electrically how you carry the 1 and get the next column to advance, okay? So at the very top up here, this is the same switch we were just looking at, right? I've got a target that's worth 1 point. Every time I hit it, I complete the circuit through the 1-point relay. The 1-point relay now is going to close the switch down here in the circuit to the 10-point relay, okay? So every time I get 1 point, this switch is going to close. But there's a second switch here that's only going to allow that circuit to take effect if my 1-point score reel is at position 9. So the first time I hit that target, right, I get a path through the top coil, and notice the switch in that second circuit is also closed. It's trying to let current through, but because that 9-point, this switch hasn't closed yet because I'm only at 7. And when when this top switch opens up, everybody relaxes, and I roll forward to 8. And I can do it again, and I activate the circuit. I'm going from 8 to 9. It's just like the previous one. I end up at 9. Okay. The next time I hit that target, I'm going to close complete both circuits now. So you can see that not only the 1-point circuit, but also the 10-point circuit is complete. So now both score reels are primed and ready to walk forward. And when the switch finally opens up, both score reels walk forward 1 position. Good? And I'll show you how that works. So there's a 9th position switch that's back here. And when I walk forward, 8, and when I get to 9, one of these switches is going to change. And that will allow my carry. And I encourage you to come by afterwards and do this for yourself. It's way better in person. Okay? So that's how those two circuits are working together. Let's step away from score reels for a minute and talk about a lock-in circuit. This is a fundamental circuit that's used over and over and over again in EM games. And it's important to understand how this works to get past these simple circuits into more interesting circuits. And the way this works is that there are two paths. Here we go. So I have one relay coil, just like before, and I have a transformer, just like before. I have one switch, which I'm just calling activate. It can be anything. It can be a target. It can be another relay. But this top circuit is the one that's going to make this relay fire. The bottom circuit is what's going to keep that relay active after this switch disappears. So what happens is that this switch closes, fires this relay. This relay is now going to close this switch. And this switch is already closed, right? So as soon as I apply power, I'm getting both circuits are active, keeping that coil going, right? But now this might be the activate target might just be like a one-point target on your playfield. Well, that just closes momentarily, and the ball rolls away, and that switch opens up again, okay? But if you're using a lock-in circuit like this, as soon as that ball rolls away, the switch opens on the top path, but I still have the bottom path that's going to keep that relay active. And it will keep it active indefinitely, right, until something else comes along and opens up this second switch. And I just represented that here with another target. So maybe there's another target on the other side of the playfield, maybe extra ball, right? Maybe the upper path is you've earned extra ball, but now the game has to remember that indefinitely until you use that extra ball, and that's when this thing would open up and allow the circuit to relax, okay? So that could be seconds or minutes, right? And then when that release switch relaxes, then everything is back to normal and waiting for the next activation. Yeah? Okay, so lock-in is going to become important here in a minute. Let's talk briefly about a score motor. So a score motor, this is a picture of a Bally score motor. Williams used a very similar design. These cams rotate towards you in this drawing. These little nibs will roll by and bounce the switch stacks that are mounted to the top of the score reel, to the top of the score motor, right? But notice that the little nibs are all in slightly different positions. So these are firing a little bit like the pistons in an engine in a very specific sequence and a very specific timing relative to each other. And notice at the back end here, there are some cams that have multiple nibs on them. So when the motor turns, some of these will fire once every 180 degrees. Some of these switches are going to fire 5 times in 180 degrees, okay? And for those who haven't seen it, this is a Williams score motor operating. And it always steps through 180 degrees to what's called the home or index position, and it stops whenever it gets to that position. But if you look at the cams on the left, they're activating their switches one at a time and just once per half rotation. The two cams on the right side, or the right end, those are activating multiple times every time this motor runs. So that's going to be the key to how I get from one event to multiple events. I have to engage the score motor. So a classic example of how all these pieces work now is how do I score 50 points? Okay, I have a target that's worth 50 points. The ball closes a switch very briefly, so I have one little pulse that I can work with. And now I have to get 5 pulses into my score reel because I only get it to advance 1 step per pulse. So I have to go from 1 pulse to 5 pulses, right? How is that done? So let's work down from the top. This is the 10-point relay we were looking at before, and there's a target here that gives me 10 points. Terrific. So that's for the scenario where I just, 1 pulse gives me 10 points, 1 and done, right? But there's a second path now into this 10-point relay that uses a switch on the 50-point relay. And it's using another switch over here, which is tied to one of those cams on the score motor. That's why there's a circle around it. So this switch is going to close 5 times every time the motor turns. And if you look, this chart here on the left, this is showing you the pulses that the score motor is throwing out as it's rotating. It's like if you've ever seen a player piano roll, right? The holes tell the notes when to fire. That's kind of what this is showing you. Or if you took that score motor and inked it up and rolled it out over paper, you might get a pattern that looks a little bit like this. It's showing you exactly when those pulses are in time. So the top cams are all firing just once per the 180 degrees. But the last cam or two, those are rotating through 180 degrees, but firing 5 pulses, 1, 2, 3, 4, 5. If you've ever listened to an EM game reset, right, it's dot, 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 dot. Those are the 5 pulses that come in chains like that, right? It's endemic to all the EM games. They all do it. So the way this works is, so the top path here gives me 1 point, or 10 points. The second path is what's going to give me 50 points. The 5 pulses are going to walk through there. Down here, I have a target that's behind, a switch that's behind a 50-point target. That will close this switch here. This is my lock-in circuit, right? I've got one target that's going to fire this 50-point relay. And then I've got a second path that's going to keep that thing on for some time until this switch opens. So this second piece here is a lock-in circuit that's going to remember I owe you 50 points, and I can't let go until I've given you those 50 points. And the bottom down here is the score motor. So it starts up whenever the game recognizes that it has to deliver 50 points. So I can put this in motion now, and we can see what's going to happen is that you're going to get a little sort of a radar display walking across that chart, which represents time. As it's going by, it's going to show you what switches are opening and closing. So let's do that. So it starts off, and you can see down here, the 10-point relay fires every time I'm going over one of these bumps, okay? Because my 50-point relay, this is awarding me 50 points, it remembers, it has to remember the whole time. And that's what's keeping my score motor running. So the motor runs through an entire 180-degree cycle, and it's throwing out these 5 pulses that are ending up in my 10-point score reel. They're taking 5 discrete steps, right? And the motor runs until the very end, which this switch that lets the motor stop is way here on the right side. It's after those 5 pulses have gone through. I say, OK, I've given you the 50 points I owe you. I'm done. I can let the motor stop. And this just loops through, showing you the same thing again and again. Does that make sense, basically, how that works? So there's basically, I owe you 50 points, and I have to remember, and the score motor is going to send pulses. And the key is this switch here that says, let these pulses through, right? So it's not every time that the score motor runs. I mean, the score motor can run for other reasons. And these pulses are going to come through this switch, but it's only if I actually owe you 50 points that it gets through both switches. Okay? All right. So another interesting thing the score reel has to do is at the beginning of the game, you have to get back to 0, right? I've shown you circuits that advance the score reel, right? Oh, and let me show you the 50-point, how the 50-point works, right? There's an extra relay here. There's something here, the 50-point relay is here. And it stays on for the entire duration to keep that score motor running. In fact, I'll just let you hit that button, and you can frame it any way you want. So one of these is chattering. One of these relays is firing my 10-point relay. And the other one is staying on, right? And it's staying on for the duration until it knows that the 50 points have been awarded. OK? All right. Thank you. Resetting back to 0. So there's a little bit more complexity here. We're kind of sneaking up on it. So at the beginning of the game, all the score reels need to come back to 0. So I can't just keep throwing arbitrary pulses at my score reel because it would just keep rolling forward. So there has to be another piece of intelligence in there, another switch somewhere that says how far to roll forward. And it turns out that every score reel has at least one, usually 2 switches on it to identify when it gets to 0. And if we walk through this circuit, again, the transformer up here, this is the score motor that will start running when the reset relay fires. So when you start your game with your replay button or you drop a coin, the first thing that happens is that the reset relay fires and resets your score reels and your bonus count and trip relays and all sorts of other things. So the reset relay is the cop who says, I need to keep going, still not done with reset. And this is the circuit here for the reset relay down here. And it starts with a start button. And then this whole business down here, this is the lock-in part of the lock-in circuit. And that will keep this reset relay active until all the work is done. Notice here that there are 2 switches that say that are closed when the score reel reaches 0. No, they're open. I'm sorry, they're open when the score reel reaches 0. They're closed otherwise. So when I animate this, we'll see that there's 2 different values on my score reels, right? So they're going to want to take different numbers of steps to get back to 0. The ones digit here is going to stop. It only gets 3 pulses before its 0 position switch opens up, and it won't walk past that. And it's the second score reel that requires the motor to go through a second cycle. It's keeping the reset relay active, and it's going to make the motor go through a second 180-degree cycle here to get the last couple of pulses to get it back to 0. And maybe what I'll do is I'll play that again, if that helps. And these animations and a lot like them are all on my website, along with a lot of devices that look a lot like this one, with much better and more thorough explanations of how they work. But what my motivation here is that I want you to come back to the booth and pick up a score reel and figure out, where the ninth position switch is, where the 0 position switches are, things like that. See if you can, if you're not familiar with them already, figure out what switches are doing what and how they're used in these circuits, because they're common to all of your score reels. And then the last thing I'll do is demonstrate that here. The last button is the reset button. And it will walk through however many digits it needs. So that the middle score reel here is showing a 9. Let's put one here. So this only needs to take 1 step forward. This one only needs to take 9 steps forward. And this one will need to take 6 steps forward, right? So their 0 position switches are all going to change at different times as this motor is running, and they will stop independently. Question?
And that is because you shut off the carryover circuit, so you don't have to worry about if you gave extra pulses to the 10s because of the carryover.
Yes, the carryover, I sort of simplified that circuit a little bit. The carryover circuit is smart enough to recognize that I shouldn't be doing this if we're resetting. So there's another switch that I did not demonstrate that will it makes these circuits exclusive. Okay, so go ahead and hit that last button. Okay, and we can do that a couple times. Try that again. So all the circuits we've talked about are represented here on this board. And again, I invite you to come out and try them for yourself. See if you can identify which is the reset relay, which is the 50-point relay, et cetera. And please come by and ask any questions you have. That's what I've got.
Okay, there's always questions online about why is my score reel doing this? And I think you've got the whole chart here of, you know, the reel keeps turning around when I'm resetting, or the points don't, I can hear a relay clicking, but the score reel doesn't step, and each of these switches explains each of those different problems.
Yeah, so when you have an issue when your score reel or your motor isn't behaving as it should, it helps tremendously to understand how it should work. And then try to imagine a scenario where it would, you know, maybe my score never carries over, right? Well, you might remember, well, there's a switch in there that has to happen, has to close to make that carryover happen, right? I know my score reels work independently, so the coils must be good, but there's something broken in the communication between the two of them. And so that might help you narrow down to one or two switches once you get a handle on looking at your schematics. And understand, you know, same thing with reset, you know, trying to understand what parts of the, you know, what is the mechanism that gets those pulses into my score reel, and how does it know when to stop, things like that. And that will help you zero in on a schematic, and then you can just go and find those switches in the game and try to see if they're working properly. Question?
How does a motor know when to stop turning?
How does a motor know when to stop turning? Excellent question. So let me back up and maybe I have a picture of that. Yeah, so look carefully at this drawing. This is right out of a parts catalog. Thank you. Notice how most of these drums, or most of these cams, have nibs on them, right? So the nib goes under the switch stack and bumps up the switch. The first one actually has a gap instead of a bump. So that's kind of working, it's letting its switches drop instead of raising them up. Well, this first cam is used, among other things, to keep the motor running to the next gap in that cam. So once I start this motor, I can actually even just push this coil forward. Usually it's a circuit that electrically gets the motor to start. But I can walk this forward enough to activate this first cam, or this first switch here. And the motor knows that it has to run forward to the next home position. The motor can't just stop arbitrarily. It has to be ready for the next computation, the next bit of math. You may notice, for example, a lot of EM games have targets that say, you know, blah, 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 when lit. And that light will often go off when the motor is running. That's because the motor is committed to doing some calculation, and it can't start a second calculation until it has finished the first one. So it disables some of the more elaborate things on the game while it's doing the math to figure out what it owes you. And when it gets back to the next position, it's ready to start the next thing, whatever that is.
How about, since people always ask about the, I'm resetting and it doesn't stop resetting, the reel keeps turning, I think you can.
The score reel or the motor?
The score reel and the motor.
So the motor,
Making the score reel turn.
right, so the motor, you know, common complaint, my score motor won't stop turning. And there are a lot of reasons that the score motor turns, right? It'll turn for 50 points, it'll turn to count a bonus, it'll do all sorts of things. It's used for all sorts of things. But during reset, right, I mentioned that there's zero position switch. There are actually two of them. One of them I showed blocks, one of them I mentioned blocks any more pulses from walking the score reel forward, right? So if I'm using the reset circuit, it's going to go through a switch that says, well, don't take any more pulses once I reach zero. Okay, that's one zero switch. It turns out there's another zero switch that talks to my reset relay. And the reset relay needs to hear back from all of the individual score reels. And it will, until it hears back from each one, it says, well, somebody out there still hasn't reset. So I'm going to try again and send it through one more cycle here. And send it another 5 pulses, see if that'll get it to 0. Well, if the motor keeps running, it might be that one of these score reels has not reported home again, right? And you might think that's a bug. You might think, well, why doesn't it just send out 10 pulses and stop, right? And that would work on a new game, But an older game that has some wear or some dirt, maybe you have trouble getting past 9 into 0, and maybe it takes 3 or 4 tries. Well, that's why the motor keeps running. It says, well, okay, I'll give him a second chance, I'll give him a third chance, and eventually, you know, for a while, it will walk to 0 eventually if you give it enough pulses. So I think that was done by design to keep the motor running until it has seen from each individual score reel that they're all back at 0.
What else do we often hear?
Well, I don't know if we often hear it. I was asking about the score motor chart that you posted. That's on the schematic. Is that, are those position indexes on the schematic as well? Is that accurate, or is that something you created?
No, that's lifted right off the drawing.
That's right on.
Well, I recreated it, but it's that most schematics will have a score motor chart. They don't all, but most of them do. And they represent the pulses that are coming off whatever motor you're using. The charts will look different across manufacturers. This is what a Williams chart would look like. But they all have similar information. And the key is that, you know, when does this thing happen in relation to that thing, right?
Yeah.
And they will never swap their order. So, you know, something that's controlled by an early switch will always happen before something controlled by a later switch. And you can sort of tell based on these blocks. And that doesn't tell me when the switch closes or when it opens. It just tells me that it changes, right? Because some switches are normally closed. Some switches are normally open, right? This just tells me when it changes, right? When it changes position.
You can see there that the 50-point relay itself has to be done before you get near that index switch. Otherwise,
Yes.
the 50-point relay would still be on at the, and you go around again.
Yes. Let me see if I can.
There is some timing at
Right.
the end of the.
So these are the 5 pulses that are awarding my 50 points, right? And they correlate to these. They'll even turn green, right? When it's activating something, that block turns green. And then the last one here is going to turn green. All right? And then it's this pulse that's later that's going to finally let my 50-point relay relax. Okay, so I know based on the profile of these cams that those 5 pulses have done their thing before I allow that 50-point relay to let go. And there is no feedback mechanism there. You don't get a second and third bite at the apple to try to make sure you got the 50 points. This is just one and done, and they're counting on it working properly.
And that's all called Boolean logic. That's a ladder logic. That.
Yeah. So the Boolean logic is way back here, right? It's where am I? Way at the beginning. It is used to describe the combinations of open and closed switches that you're working with, right? And the beauty of Boolean logic is that you can describe it in English, right? That first circuit at the very top, that bulb only turns on when A is true and B is true, right? And the second one down is the bulb comes on when A is true or B is true. They're very different things, right? And just by changing the configuration of the switch, I can change the behavior of that bulb, or that can be a relay, that can be a step unit, that could be any electrical device that needs current through it, right? Just by manipulating and changing the configuration of the switches that go into that device, I can affect when it happens, right? And this can be arbitrarily complex. This is this among the simplest examples of combining switches, right? But if you look at a real schematic, most circuits will have 3, 4, 5 switches and multiple branches, right? And it's the combination of those things that you have to learn to unwind to figure out what makes that device happen.
Yeah, I think in a big schematic, you often see that they're trying to economize. Like there'll be on a Gottlieb, it would be a motor 1A for 5 pulses, and there's just a whole bunch of stuff coming off one motor 1A switch.
Mm-hmm.
So that's the branching like you see on A or B, this great big branch, so that they economize on the number of switches on motor 1A.
Mm-hmm. And, you know, if you're unfamiliar with schematics, they can be pretty intimidating. it's a lot of wires and whatnot. But I use the analogy of, the schematic, think of it as, you're on vacation, you've traveled to a new city, and you're looking at the subway map, right? Nobody memorizes the subway map. Nobody understands every stop in the subway map, right? You care about getting from point A to point B. You find them on the map, and you figure out what connects those two, right? And 98% of the subway system, you couldn't care less about. You just care about getting from A to B. Well, reading a schematic is kind of the same way when you're troubleshooting, right? I've identified something that's misbehaving. I think I've identified, the coil or the relay that makes that misbehave. So I'm just looking at what circuit, what are the 3 or 4 switches that make that device fire? And I'm looking at a circuit that looks like any one of these lines, right? Start there. And the rest of it you can ignore for the short term, right? You don't have to be intimidated by the whole newspaper schematic.
Yeah, and that reminds me of another thing that on inside there's often, someone will say the 10-point switch is not scoring, and one of us will come on and say, what if you push in the 10-point relay yourself? Does the 10-point relay do the right thing, so therefore it's not activating the 10-point relay, or is it that you hit the 10-point relay and
Right.
further downstream is something?
Right. So to get 10 points, right, there's a switch behind a target, and that fires a relay, and the relay fires a score reel. Well, initial observation is I don't get 10 points, right? Well, at a high level, there are 2 circuits there. So just by knowing which relay is supposed to fire, I can observe without touching anything. I can just observe, hit a 10-point target and see, does that relay fire, right? If it doesn't fire, the problem is not my score reel. The problem is my relay, right? If my relay does fire, well, I know that the target can talk to the relay, so I can eliminate half of my problem and now focus, why don't I get from the relay to the score reel, right? You divide the problem in 2 and see if you can isolate one from the other, and keep dividing by 2 until you figure out, what the issue is. Yeah.
When you're troubleshooting, is there like a tool you can use to like send current through a part of the circuit, like you just touch it?
Yeah, absolutely. So if you have a jumper wire, which is a piece of wire with alligator clips on either end, I can jump in there. If I suspect that this switch isn't closing, I could jump in there with a jumper wire and jump to either side of that switch and provide a bypass around that suspected switch. Well, if the circuit starts to behave or behaves differently when I clip in there, that tells me that my problem is between what I clipped into, right? So if I've bypassed one switch, the problem is likely to be with that switch, because once I remove that switch from the circuit, things start to flow. And that proves to me that all the other switches in the circuit are working, right? So that would be the simplest debugging tool, troubleshooting tool.
Question, are there any noteworthy differences between the manufacturers of the score wheel?
Are there noteworthy differences between the manufacturers of the score reels? Some are a lot easier to take apart and put back together than the others. Functionally, they're all essentially the same. They will have 0 position switches, 9th position switches, et cetera. They will all have the same basic stuff, but the engineering and the way it was put together got better and better, I'll put it that way. So the more modern ones tend to be easier to take apart and clean and whatnot, which is going to be important to all of you at some point. But yeah, there's certainly subtle variations. And I have back at my desk, I've got a box full of loose score reels of 3 or 4 different manufacturers, and I encourage you to take 2 of them and compare and see if you can figure out how it's done on each one.
Yeah, and then like a little chart or a GIF of different, like Valley does 0 to 9 one way, and Gottlieb does different, and Williams does it another way, I don't know.
There is a chart that floats around. I don't use it. I tend to come at the problem a different way, but that certainly seems to help some people. I don't want to have that with me if I'm on a job repairing a game. And I don't want to commit it to memory either, right? Because it's not just a matter of the 3 manufacturers, but it's also different eras changed what those switches do. So you might have 2 or 3 different flavors of Bally based on what year the game came out. That's way more than I want to carry around up here. I'll just look at the schematic and figure out what it's supposed to do.
Yeah, Gottlieb kept improving the mechanics of their score reel, even in the mid-70s, when they already knew solid state is coming, and they just kept, making the nylon thing a little better, smoother acting, less likely to jam up, and the ratchets would have less wear on them, so they wouldn't wear out as quickly. The end of stroke switches, I guess, they had those real short end of stroke switches that broke off because they were just getting so much flexation on a short blade. What else? The end of stroke switches is really a big trouble spot for a long time.
I think of getting the coil out and cleaning the coil sleeve or replacing the coil sleeve. Some of them, getting it back together is it's like those puzzles with blocks that only go together one way, Some of those score reels are kind of like that. There's a secret way to get them back together, and I don't have that committed to memory either. I have to figure it out every time. Some of them go a lot faster than others. But it's good practice, right? That's something you will have to learn to do, and just do it. Take it apart slowly and carefully, and take pictures, and then retrace your steps after you've cleaned everything, and you'll get through it. It builds character, right? I mean, if it's hard.
Any other? Okay.
Very good.
Thanks, Mark.
Thank you, everybody.